Alright, so these are some quick notes on 10.1 and 10.2, which is areas of parallelograms and triangles. Not everything that you'll see on the screen today is on the note paper, but most of it is. So basically the goal is to be able to find the area of a parallelogram and a triangle. And the good news is that we're going to be able to go pretty quick because this is pretty much a review. So the first thing you want to remember, just recall, is the area of a triangle is base times height. So if you think of a triangle, let's say, for example, it's 10 by 3. Well, then you know the area of that triangle is going to be 30. And this shouldn't really be a problem at all for you. Okay, so that's pretty clear. Then we want to understand how the area of a rectangle and the area of a parallelogram is the same. And this is really big because if you can remember this, then you don't have to ever really memorize the formula. So let's say, for example, the height is always going to be perpendicular to the base. So it's always an altitude to the base, or you can just say it's always at 90 degrees. So that's how you have to measure the height. Imagine if you take a tape measure and you want to measure the height of your friend, or the height of a chair or something. I don't really know. Just thinking of things. You're going to have to take the tape measure and make sure it's straight perpendicular to the ground, forming a 90-degree angle. That's how you get the height. You can't get the height if you're going slanted. So this is not the height, but this is the height. So that's important to know. That's an x, not like a algebra x, but a no x, I guess. Okay, so let's imagine that we have... Okay, so imagine that we have a parallelogram that's very similar. So this parallelogram is 3 tall, and it is still a base of 10. How does it make sense that this parallelogram would have an area of 30? Because that's what I'm kind of telling you. Well, here's the reason. If you think about it for a second, and I want to use some colors here to make this understood. If you look at this right here, this green rectangle. Well, what's the base of that green rectangle? It's 10. And what's the height of that green rectangle? It's 30. So that area of the green rectangle is equal to 30. Just like this, basically. But what you're noticing is what's happened to the green rectangle and the black parallelogram. What's different about it? Well, the important thing to notice, this is huge, is to understand that this triangle right here has been grabbed and moved over to here. But basically you're just slicing a triangle off of the left side and moving it to the right side, and now you have yourself a parallelogram. So shouldn't it still have the same area? Yes, that's the answer. So therefore, the black parallelogram will still have an area of 30. And hopefully that all makes sense. I mean, it's a little bit overwhelming visually, but I think it's pretty straightforward once you see that triangle sliced off and moved over. So that's what we're trying to understand. Alright, so that's kind of all there is to say about that. You might have to find the area from the base and the height of a rectangle or a parallelogram, or you might have to find the height or the base from the area. But really, it's just a matter of whether you're solving for this, whether this is your variable, or you're solving for this, right? That's really just all you need to know. Is it that you're solving for, the area, or is it the base or the height that you're solving for? But really just one extra step, if you think about it. Okay, so the base can be any of the sides. It could be the sides. It's not always the sides because it's always going to be the altitude. I guess depending on how you rotate the shape, the base could be any of the sides in every situation if you rotate the shape properly. But you can also just draw a perpendicular to make the base. So that hopefully is helpful. I didn't give you a lot of writing because I'm trying to do these notes quicker. So the base can be any of the sides, depends on the altitude. The altitude's got to be perpendicular to the base, so just like we were talking about, so I won't recap that. And then the height is just the length of the altitude, or the length of that section that goes perpendicular to the base. So you might see this little drawing down here. The thing that you got to understand is that the base is, let's kind of do some color coding here. So what I'm going to try to do is, I'm going to split this a little bit, and I will show you the base, okay? So the base could be any of the sides. In this case, here's the base. It's this thing, right? And that's the base. But if you rotate this shape, if you think about it, and you took this exact same shape and you rotated it, couldn't you imagine that this is also the base? If you want, if you rotate it properly, you could just call that the base. So it kind of could be any of those things. Also, the height is always perpendicular to the base. So in this first instance, this is the height if you rotate it, but this is the height normally. So here's your normal height on the left side. But you see how that rotated, if you look at it differently, if you rotate it this way, I'll show you what I'm saying. This is really just this. Hopefully this video actually displays better than this one is, because it's kind of squished on my screen. So these should be the same. They're both the height. So you can either rotate the figure to get the height, or you can just know the height without rotating. So here's like knowing the height without rotating. This is knowing the height without rotating. You're just going perpendicular to the other side, and this is rotating it and then getting the height. That's kind of what's happening. So be aware that you can rotate to get the height. The height could be any of the base could be any of the sides. The height usually has to be perpendicular, so not always a side. Oftentimes not in a parallelogram. Okay, area of a triangle should be a pretty quick and easy thing. I believe you have this in front of you. So the area is 1/2 base times height. So that's good. I don't think we need to really even talk about that formula because you've seen it for many years. Remember again, the height is always perpendicular, okay? So in this case, there's the height. Just talking about the height for a second, just so we're like kind of clear on it. Remember, the height is always perpendicular, so here's the height of that parallelogram. Whatever you got to do that goes perpendicular to the ground. So let's do a couple examples. So look at the example, think about it for just a minute, and think about what you think is the height of this triangle. Okay? There's a couple of different ways you could actually do this. So you could find the area of the triangle by doing the base times the height here on the bottom and the left, or you could do it here with these two. And we'll do both of those in just one moment. All right, sorry, having to pause this video quite a bit, but we got to make a couple changes to this because these numbers aren't going to work out. I have been informed, so that's one thing we're going to want to fix. So I've come up with some new numbers, so go ahead and just scribble these out or whatever. It's not like you can erase them, I guess. So we're going to make a change here. The bottom will make us 3, then will be 4 and 5. So there's your typical 3, 4, 5 triangle. And then what I'm telling you is that we should have a couple different things. We can come up with the area 2 different ways, or I could make you come up with that altitude. There's a couple of different ways I could run this problem. But why don't I just show you it first with this given to you. So this right here is going to be 5 over 12. Or sorry, 12 over 5. My mistake. Okay? And I guess just so we have it in a decimal form so we don't see any like crazy similarities, why don't we just make that 2.4? As long as I've done that math out right, I think I'm good. Okay? So there's that height. So let's look at the area in 2 different ways. Let's first look at the area the way that you would probably normally find it. Area equals 1/2 base 3 times height 4. That's 12 divided by 2. That's an area of 6 units squared. Okay, I just put a U for units. I'll usually put a tail on my U's so that you know that they're a U and not a, I don't know what else it could look like, but I'm sure there's other things it could look like. Okay, so now we'll look at the next one using a different color. If this was the base and this was the height, so you're imagine you take this and you spin it clockwise until the 5 is on the bottom and the 2.4 is your height. Well, now we're going to have a different area. We could find it this way. 1/2. The base is now the 5, and the height is 2.4. Okay, so what does that come out to? Well, 5 times 2.4 is going to be 10, 12. So we're going to have 12 divided by 2 because 12 times 1/2, and that's going to come out to 6 units squared. So what do you notice is that you could have found the area the blue way or the red way and still came out to the same thing. Sometimes the height, you can't really get it by drawing it inside the triangle. Don't forget about altitudes that meet outside the triangle. So that's what this is here for, to show you that the height is sometimes on the outside And sometimes you have to just pay attention to that. So sometimes you have to extend the lines. Don't forget about that section we covered a little ways back. Okay, I'm going to keep moving. So we're given the area and we want to find the missing side or altitude. So I'm going to give you the area and I want to know what this is, and I'm going to call this a now you try. So why don't you pause the video here and give this a shot and try to figure out what the missing side is, the question mark. Okay, so pause the video, give that a shot. All right, so hopefully that went well for you. Don't forget to ask for the answers in class. So look at this parallelogram here. This is not in your notes, I don't believe, but I'm just going to kind of show you a quick thing. So this is something you can kind of just zone out a little bit for. So what you want to do is think about the shape rotated. So you look at the green one that's rotated, right? So if you think about this right here, you have this 7.1 right here. That's your height. And your base is, I would say, 11. So these are corresponding to this. That 10.2 is not going to really help you in this problem. There are situations where it could. And at that point, you just want to do area equals 1/2 base times the height. Some people might ask, can I just do the base times height and divide by 2? Yeah, of course. Of course you can do that. You can just do the base by height and divide by 2, but I think writing it out will make you not forget the 1/2 because people can forget the 1/2. So you can always put this problem in the margin. That's what I'd prefer you do, unless you legitimately have no space whatsoever. So let's go on to one more. Okay, so this one. This one's in a good situation as far as everything is concerned, but you have to notice that you're extending out to get the height. So don't forget about that. So area equals 1/2. The base is pretty clear. You could use this or this for the base, but I usually just use the one on bottom. We know it's a parallelogram. Just FYI, these are parallelograms. I mean, that's what the section's about. So if you know the top, you know the bottom, because of parallelogram rules. That's why we did all that studying. So 1/2 base times height. And you just crunch those numbers. I'm not going to bother with it in the interest of time, but you would just crunch those numbers to get where you need to get to. One more example, just showing you examples so you can kind of go through it. I think we're okay with this, but if we do area, which they gave us, equals 1/2 base times height, which we don't know, that's how I would set this problem up. This is this, right? That's the unknown. So I think at this point you could solve that equation. I'm not going to bother solving it. Okay, so 10.2. 10.2 talks about trapezoids, rhombuses, and kites. So we want to be able to find the area of kites, trapezoids, and rhombuses. They're really just made up of triangles and rectangles for the most part. I mean, I could be wrong. There could be some situations where they're not, but you could break all of these things into triangles and rectangles for the most part. So basically, we want to be able to find those areas. So an area of a trapezoid is this right here. You might want to just say it over a couple times just to memorize it. It's an important formula to kind of have in your brain. Area is 1/2 base 1 plus base 2 times height. I learn this with the height here, so I'm always going to say it this way. 1/2 base 1 plus base 2 times height. An alternate way to look at it, area of a trapezoid, I put a T for trapezoid. I guess that looks like a triangle too, so maybe TRA. You could do base 1 plus base 2 times height divided by 2. It's just like with the triangle. So finding the area of this trapezoid, I encourage you to pause the video and try it if you can. But if you don't feel like you are able to do this, then keep playing. But maybe pausing it and knowing if you're there would be a great thing to do. So what this would be is area equals 1/2. Base 1 is here. It doesn't really matter which one's base 1 and base 2 because you're going to be adding them together. And if you think about 2 plus 5 is 7, 5 plus 2 is 7, so it doesn't really matter which order you add those in. You just want to make sure you have them both. So base 1 and base 2 doesn't matter in this circumstance what order you do that in. And then we got to multiply that by the height, which is here, which is 4. So I guess we have 2 times whatever that is, because the 4 and the 2 will give us just 2. So area equals 2 times this. 4, 5.4, 2 times 5.4, so 10.8 yards squared. Do not forget about your units. Yards squared. So moving on. Sorry if this video is fast. I'm hoping that a lot of this stuff is pretty familiar to you. Here's one where we're given the unknown unknown base. So I want you to try these two as a now you try. So this is your now you try. I think you're really just using the techniques of the formula I just told you, and you're finding a missing side. So you have the area. So you've got to put an x somewhere into your formula, into your equation. So pause the video, give this a shot.
Is there a word for journey?
So what we're going to do is we're just going to stop the video here. So I know your notes are 4 pages or 2 pages front and back, but we're not going to make it through. It's going to be too long. So stop here. Make sure you get the now you tries done. So circle back and get those done. And we will talk about trapezoids, triangles, and parallelograms in class. And we'll leave kites and rhombuses for later. Okay, I will see you soon.